So now that we proved that the arc-length formula exists and works and is lovely, let's actually put it into practice. We're going to determine the arc length of this curve, which is f of x equals the square root of x cubed, between x equals 0 and x equals 4. Now I have no idea why I wrote it this way because, of course, if we're going to have to be doing calculus with this problem, we're going to want to rewrite this as x to the 3 halves. Right? We know an integral and a derivative are involved for starters. All right, so let's write that. F of x is x to the 3 halves. I know in the formula I'm going to need the derivative, so I might as well find it right now. So it's 3 halves x to the 1 half. Wonderful. Now I want to find the arc length. The arc length is going to be the piece of this curve that's between 0 and 4. So right there, that's what I'm finding. From this point to this point. And I know it seems crazy, but that is not something that was able to be solved until calculus came along, because we don't have the geometric tools to be able to do that from geometry or from algebra. We just don't have the math toolkit. You need to have calculus to be able to do this. All right, so let's write down the formula. So the length of an arc is the integral from a to b, the square root of 1 plus, this is obviously a function in x, so I'll say f prime of x squared dx. Make sure that you have your square root denoting where it ends. Sometimes students extend it too long or not long enough, so it does go after the f prime of x squared. It's right there. All right, now a and b were given, so that's going to be pretty easy for us, because they told us that they want us to go from a, which was 0, I'll just put it in 0 and 4. We know that it was 1 plus, and then the derivative was 3 halves x to the 1 half squared. All right, well, that's the integral of, or from 0 to 4 of the square root of 1 plus 9/4, because 3 squared and 2 squared is 9/4. X to the 1 half squared would be x dx. Now, they didn't say this, but we can do this one. This one is doable as a U substitution, so let's use that. So U is equal to 1 plus 9/4 x. And of course, when you're using U substitution, you do need to show your work for the most part. So du equals 9/4 dx. And I don't want the 9/4 with the dx, so I really want 4/9 du. And of course, because this is a definite integral, I need to find my new limits of integration. So when x was equal to 0, u is equal to 1. Well, u is equal to 1. It's 1 plus 9/4 times 0, which is 1. When x was equal to 4, u is equal to 1 plus 9/4 times 4, which is 1 plus 9, which is 10. So when I rewrite my integral with U substitution, I'll never need to go back to the 1 plus 9/4 x, because I'll just be able to say from 1 to 10. I have a 4/9 kind of in front here because it's a constant, so I might as well just take it out. And then instead of the square root of 1 plus 9/4 x, it would just be the square root of u. And then du, which is a much easier problem, right? Similarly, this is equal to 4/9. Of course, as per usual, we don't actually want the square root part. So we really want u to the 1 half. That's much more practical because we have a power rule. We don't have a square root rule other than the power rule. All right, so we will add 1 to that power and then divide by that new power, or we'll multiply by the fraction. So this is equal to 4/9 times 2/3 times u to the 3 halves. And we'll take that from 1 until 10. All right, so 4 times 2 is 8, 3 times 9 is 27, so that's 8 over 27. and then it's 10 to the 3 halves minus 1 to the 3 halves, which is 1. So that's easy. And that would be 8 over 27. 10 to the 3 halves is 10 square root of 10 minus 1. And that would be meters, because they said X and Y were in meters. So it would be meters. Now, as per usual, I'm going to double check myself with Desmos. So I have this graph right here. I've kind of dotted the arc length portion that we're looking at. That's the best I could do here. All right, and then, okay, so you can kind of see it better. Now the arc length calculations are right here hidden. So there's the original arc length, and then there's my answer. And you can see that my answer is correct. It's 9.073. So I could say that. It'd be about 9.073 meters. Of course, if you're doing this as like a worksheet quiz for JetNet or something like that, or my stat lab, they might, or my math lab, excuse me, they might ask for a decimal approximation. So it's always good to write them both.